Hello, in this video we'll be looking at Suvat equations again, and we'll particularly looking at how direction and vectors affect what you do. So let's start with a situation. Say here's a question. A ball is projected up, that's vertically up, in the air with an initial velocity of 5 meters per second. Okay, so the question is, how much time will pass before the ball reaches its maximum height? Okay. So what I'm going to do with that question is I'm going to draw it. Okay, now I'm going to have to rub all that off. So, but you'll see it in the diagram much clearer. So, how much time will pass before the ball reaches the maximum height? Question mark. Projected at the air. So clearly, I mean, in the moment, we've only got one piece of information. But before we solve a situation, we need 3 bits of information. So where are we going to get the other 2 bits of information from to form our linear equation with one unknown? So let's have a look. Now, in this question, we're going to assume there's no air resistance because that would affect the answer. So let's draw it. So here we go. Ball being projected upwards, initial velocity 5 meters per second. It's going to go up now. You may not know this, but when you throw something in the air, it will instantaneously come to rest. Okay, this can be quite confusing when you first think about it, because, well, isn't it always moving? Well, then we're talking about the finites. Yes, it can be quite philosophical, but let's say it does instantaneously come to rest. It'll have to, because it has to change direction. So we've got an initial velocity of 5 meters per second, a final velocity here equal to 0 meters per second because it stops. So we've got 2 out of 3. Well, what else do we know? Well, we have weight acting down. So we have acceleration acting down here, which is due to gravity G. And I'm going to call that 10 meters per second squared. It is in fact often 9.8 or 9.81, but I'm going to use 10 as the acceleration due to gravity, which equals the acceleration. Now it is a vector, so ultimately it's going to be minus 10. However, I've drawn that down and that negative. Really, I should draw that up and make that negative. But it shows you what's happening. When it's gravity acting down, 10 meters per second squared. Second, yes. So, what equation, what do we know? So we write out our Suvat. S-U-V-A-T. Displacement, well, we don't know anything about that at all. Initial velocity is 5. Final velocity is 0. And the acceleration, assuming that is positive upwards, so positive upwards, and is minus 10, and time we want to find out. So we've got U, V, A, and T, heavens above. We'll use V equals U plus A, T. So we get, put the numbers in now, 0 equals 5, so that's minus 10t. Okay, so we bring that across. 10t equals 5, so the time must be equal to 5 over 10, which equals 0.5 seconds is the answer to that question. So if you throw a ball up with the initial velocity of 5 meters per second, it'll take half a second before it reaches its maximum height.